The next section involves two special right triangles. It's a pretty short section. I know you're sad about that. These two triangles that we are covering are special because they show up a lot in math. Not just in geometry, they are everywhere. They keep turning up. Maybe they're stalking us. You absolutely positively must get these down. Not just memorized where you kind of know it, not you can agonize for a minute as the answer percolates up from the depths of your mind. They need to become second nature. You need to be able to whip them out as fast and as with little thinking as doing 7 times 9. Wait, can you whip out 7 times 9? Maybe I don't want to know. Have I mentioned that these are important? First we have a 45, 45, 90 triangle. You can probably guess where the name comes from. The first thing about these triangles, and sometimes half the battle, is realizing what they are. You need to get good at spotting one of them. There are a lot of possibilities. Obviously they will often have this instead of it actually saying 90 degrees. But even more than that, people will be expecting that you no longer need 3 angles in a triangle. 2 is all you need. If you have 2, you can figure out the third. So it will be common for you to only to have 2 of the angles actually listed. These are isosceles right triangles, where 2 angles are equal. So you may see it done like this instead. Or maybe they mark the sides to show that it is isosceles. Or maybe instead of tick marks, they just tell you the lengths of 2 sides that happen to be the same. So many possibilities. They all show the same thing. Our lovely special 45, 45, 90 triangle is here. Once you have identified that you have one of these things, then you know this relationship. In a 45, 45, 90 triangle, the length of the hypotenuse is root 2 times the length of the leg. Remember, this is an isosceles right triangle, so it doesn't matter which leg you use. Multiply either leg by root 2, and you will get the length of the hypotenuse. This picture is the one you will want to jot down and memorize until it is down cold. It is really simple to use. If you have this situation, you certainly could use the Pythagorean theorem. That's not too bad, but ugh, we have a shortcut now. All we have to do is take either leg, both are 7, and multiply it by root 2 to get our answer. Boom! We're done. Easy, right? Much easier than the Pythagorean theorem. The only other possibility is we are working the other direction. You should be able to quickly see that it is a 45, 45, 90 triangle, which should immediately bring this to mind. Before, we multiplied the leg by root 2 to get to the hypotenuse. But now we want to go the other direction, so we need to do the opposite of multiply. To get from the hypotenuse back down to a leg, we need to divide by root 2. That should be trivial. It gets a tiny bit harder if the hypotenuse is not something root 2, but not by much. Here we are starting with the hypotenuse again, so we need to get to a leg. So we divide by root 2. By doing that, we get 28 over root 2. Now we need to rationalize the denominator, which is 14 root 2, which is the answer we were looking for. Not too tough, right? Now we get to the other special right triangle, the 30, 60, 90 triangle, which you can also probably guess where the name comes from. Once again, you will rarely see all 3 angles labeled, but that doesn't faze you at this point, right? Fortunately, there aren't so many variations with this one, but you have to be just as vigilant for them. Identifying them is half the battle. Once you have found a 30, 60, 90 triangle, then you know that the length of the long leg is root 3 times the length of the short leg, and the hypotenuse is twice the length of the short leg. The picture down below describes it better for you visual folks. That's the relationship you have to nail down. Now a couple of notes about this theorem. If you read the theorem closely, you would have realized that the short leg is the key to this thing. All the other sides key off of it. If you aren't given the short leg, then solve for it first. In a triangle, the shortest side is always opposite the smallest angle. So if you are looking for that shortest leg, it is always opposite the 30-degree angle. And finally, you normally only start with one side length. So unlike the 45, 45, 90 triangles, the Pythagorean theorem can't save you here if you forget the relationship. But you aren't going to forget, right? Because you're going to have it down like 7 times 9. There are only 3 possibilities with these problems. You start with a short leg, you start with a long leg, or you start with a hypotenuse. Here we are starting with a short leg, which is by far the easiest. Using our relationship blazoned on our brain, we know that the long leg is root 3 times bigger than the short leg, and the hypotenuse is twice as big as the short leg. Can this get any easier? In this one we are starting with a hypotenuse, which is the second easiest side. The short leg is the key for everything, so if you don't have that, like on this problem, then solve for it first. What do we do though? To get from the short leg to the hypotenuse, we multiplied by 2. Now we're going the other direction, so we divide by 2. The short leg is 6. Once we know the short leg, the long leg is a breeze. It's just root 3 times bigger than 6. The last possibility is you start with a long leg like here. Once again, we don't have the short leg, so solve for it first. To get from the short leg to the long leg, we multiply by root 3. But here we're going the other direction, so we divide by root 3. Then we have to rationalize the denominator, getting us to 9 root 3. With 9 root 3 as the short leg, now it is really easy to get to the hypotenuse. All we have to do is double the length of the short leg. Simple. That's the hardest side to start with, and that isn't too bad, right?